installing or maintaining or inspecting something, to take a picture and collect that information. You can also send that in from the field. If you just email it in to give an email address, it appears on the map underneath the site. And I think there's also interesting scenarios of getting the public to contribute information, say after a storm. So anyway, that just gives you a big flavour of the demo. And so I hope that helps persuade you that the likes of Google do have things to add into the more traditional applications. I still think the traditional systems will continue for a long time to be the core engine for the complex applications, but I think we can spread the usage of the data through the enterprise a lot more for these kind of systems. Another nice thing about using Google Maps is that it runs very well on mobile devices, so that same functionality I just showed you will run on an iPad over a wireless connection. The iPad has a GIS too, and on an iPhone. Basically all the same functionality with a slightly modified user interface, or an Android or whatever, anything with a modern web browser. But so I think in many ways the state of the industry at the moment is a bit like this. There's a sort of chasm down the middle, so you tend to have the traditional GIS world where everybody's heads down doing their day job and super busy and doesn't have time to go and experiment with all of these new and interesting things that might not be obviously applicable. And then you have all the people doing the new, interesting, generally more consumer-focused, although slightly different to the enterprise systems on the other side, but many of those haven't even heard of traditional GIS systems. So I think what we collectively as software vendors and users need to do is figure out ways to bridge that gap and produce the kind of applications that I was showing you just before. So let's talk a bit about the changing nature of geospatial data. So traditionally geospatial data was sort of points, lines, areas, maybe a bit of background imagery. But increasingly now it's becoming more multimedia. So one simple example we just saw, similar to what I just showed you, is the idea of georeferenced photos. So if you look at Flickr, the photo sharing website, there's 116 million geotagged photos last time I took a screenshot, which has probably gone up quite a bit by now, a couple of months ago. And so you can zoom into a given location. I did this one when I was out in Perth last week and haven't updated it since, but so there's about 135,000 geotagged photos around Perth. People can tag those, so you can search on things. So I'll search for kangaroos, and then all the kangaroo sightings around Perth, whatever. So there's quite a bit of interesting information in there, but like I said, you can also use that for your own specific purposes. I did also go to Adelaide and search for kangaroos. I managed to find a couple of pictures of him. And then I searched for the Australian bowling attack, but it said no results found. Sorry about that. And so this is the demo I already showed you, just the idea of putting polls and that kind of stuff in. And then, like I said, I think there's a lot of power potentially in publicising a phone number and getting people getting members of the public just to email in pictures where there's damage, and that can very quickly give you a good idea of damage assessment after a storm. And in fact, one of the We Do IT guys was showing me there's an application called Neat Streets. I don't know if any of you have seen that runs on the iPhone, that is exactly this kind of idea, but just geared on problems in general. If you see some graffiti or you see a street light out, you can take a picture of your iPhone and upload it. And then Neat Streets is an independent company, but they figure out the right agency to send that issue to and sort of report it to you. So there's a number of people kind of pursuing this idea of letting the public contribute to recording damage and problems of attention. But then we can go quite a bit beyond just simple photos. So this is a thing called Microsoft PhotoSynth, the temple in South America here. But the cool thing about this is these photos are not georeferenced. It's just a whole set of photos taken by different people. And purely by analysing the imagery, they can figure out how do those things overlap, what are the angles. So you get this quite immersive pseudo 3D view of an area. So think of a similar kind of thing, say inside a substation or something. You can get a very good impression. You can take further out pictures and closer in pictures. So a lot of potential for this kind of technology too, I think. Google Street View, I'm sure you've all seen before, but they've also added in a similar concept to PhotoSynth, but in a slightly different way, where you can add in, they search user databases from sites like Picasa and Flickr, and pull photos out of those, and they overlay them on that real-world environment. So again, a lot of potential for really getting a good idea of what a given location looks like. And then this next one I think is really cool. It's something Microsoft Research they call Street Slide. And this gives you a really nice kind of planar view along the street. You notice that the business names are down at the bottom here, and the address, the numbers are along the top there. So this is a really cool way of searching along a street for something that you want. So even nice little street view for certain kinds of operations. But again, you can see that if they have a similar API to Street View, just like we were overlaying facilities in Street View, you could overlay facilities on the street here, and that would be very powerful too. Another thing that's been getting a lot of interest is augmented reality applications. And now all these phones have cameras. You can hold the camera up and get a sort of live video signal. And then basically what you can do is sort of annotate the real world. So you just have these labels with information about what you're actually looking at. So again, you could just point at a pole or look at a different pole and see information about that. When was it last inspected and all that kind of thing. Now, this technology is, I think that the compasses and the cameras, to me, are not quite accurate enough to where this is sort of cool when you first look at it, but in a lot of cases it's just not quite accurate enough. Now, I think the compasses will improve in accuracy pretty quickly, but I think when it's really going to become even more useful is when you sort of combine this idea of image matching technologies that we saw with PhotoSim with the combination of the compass and the location. So as you move the compass around, you can match it against what you know the street view like background looks like. And this is another thing that Microsoft actually has in their labs. So here that's exactly what they're doing. They're looking at an image of somebody looking around their phone. You really can overlay extremely accurately information on that background. So that sort of augmented reality idea is getting very close. A lot of interesting things happening in 3D too, though I think in general I see these being less applicable to most utility and telecom applications, except maybe for a few specific things like handling wireless signals and that kind of thing. But this is a model that Microsoft produced of New York in 3D, all completely automated and flyover data, although Microsoft has actually kind of backed off doing these 3D maps a bit. But there are other companies doing it. This is a company called C3. It's a small company from Sweden. And this might look just like a video of flying over Las Vegas, but it's actually a computer-generated model that's completely automatically generated from them doing flyover data. So, really impressive fidelity of the data in there. And then this is one example from the gaming industry, as I mentioned before. I think often new innovations come from the gaming industry, and I suspect we'll see quite a lot of influence from the gaming industry over the next few years, especially as utilities are seeing a lot of older folks retiring and having to replace them with younger kids coming from college who've grown up with PlayStations and Xboxes and look at our user interfaces and say, what are these things? Why can't I just fly around here? And there's going to be a lot more pressure for more dynamic user interfaces, I think. And so that's all about the sort of nature of the data that we're storing, but then the sort of currency of it is changing dramatically too. So you hear a lot about the sensor web. We've got all kinds of sensors out there, traffic and weather, those kind of things, feeding in information all the time, often wirelessly. And then in the utility environment, a lot of move towards the smart grid and smart metering. So you're getting all kinds of real-time information in from those sensors. And then location-specific sensing too. So, like I mentioned, almost all phones are location aware now. We've got things like RFID tagging all kinds of devices. So we're really starting to be able to track all kinds of things in real time. And so that's leading to new data sets like this. So TomTom a few months ago announced a new traffic data set that's derived from 600 billion speed readings from users over the last 1 to 2 years. And that can give you the average speed on any segment of road in 5-minute increments throughout the week, at any day and time. And you can get real-time data within 3 minutes. So this can start to have quite a bit of impact on, say, optimizing dispatching or planning routing. So if you're planning work for the next day, you can look at what's the typical traffic and factor that into your calculations. And then also add in the real-time traffic when you're actually traveling, so you can avoid delays. You can also track cricket balls in real time, amazing what you can do these days. So make sure the game is fair, but we won't dwell on that. And then you've got location-based service is really becoming real finally. So these have been hyped as the next big thing, probably since the late 90s. But again, going back to things like the iPhone and the fact that applications can know where the phone is all the time, and I think we haven't really started to take advantage of that fully for mobile applications and utilities yet. So really just driving things based on the context. So if you're on a certain street corner, you know the important facilities that are close to you, you know that person's work schedule for the day. So you should be able to bring up the relevant things automatically without them having to type anything, for example. And so we really are approaching the point where we'll have the ability to know where everything is and what's happening all the time, which is exciting in some ways and a bit scary in others in terms of privacy issues and that kind of thing, more consumer-related applications. But again, in the sort of utility telecom context, you've got kind of two parallel tracks there. You've got the whole smart grid, smart meter, smart device trend, giving you much more real-time information about what's happening on your network, and then you've got these kind of location tracking devices giving you much more information about what's happening off the network, where are your people, your trucks, your assets that aren't connected to the network. So I think historically geospatial applications have been more about documenting what's happened in the past or what's out there and planning for what's happening in the future, with a fairly small subset of applications really focused on what's happening right now, what's real time. And I think we're going to see a great expansion of that those kind of real time applications. You get much more in the way of wireless sensing. So let's talk a bit about crowdsourcing. It's another big trend. So you hear a lot about Web 2.0 versus Web 1.0, and the difference between those two things really was Web 1.0 was all about publishing. You could put information on a website and lots of people would come and read it, but it was really about one-way communication. The idea of Web 2.0 is that people, visitors to a website can add their own information, and that really increases the value of the site. So Amazon.com is one example where lots of people add reviews, and then that really helps you in deciding what you want to buy from it, that kind of thing. And another well-known example is Wikipedia. So I'm sure you're all familiar with it. It's an online encyclopedia where anyone can edit any entry. And when you first hear about that, you think, well, that sounds kind of crazy. How can it possibly be accurate? But the reason it works is because of this community idea. So if somebody puts something wrong, there's 5 people who will correct it. And there have been several studies now that have shown that Wikipedia is as good as or better than Encyclopedia Britannica as an information resource. And so can we apply this to mapping geospatial area? Well, the first time I really saw an example of this was Hurricane Katrina in New Orleans. So I had several good friends in New Orleans. They'd evacuated. Of course, once the hurricane hit, we all wanted to know had their homes been affected, and so we were hunting around online for information. And this site was by far the best site that was available for probably the first week after the hurricane hit. And so it was just a very simple site. It had been put together by a web developer in 2 or 3 hours. He'd actually never seen Google Maps before. And it was very simple. You could just go to a location on the map and add a pin and say there's 6 inches of water at the corner of the canal and Burton Street or whatever. And there was no validation or anything like that. But you could just go and click on a